we're covering the section vectors. So a vector is a physical quantity that has both a magnitude and a direction. So a vector has two things, a magnitude and a direction. Now, it's a bit difficult to understand with the definition, so let's imagine something. I want you to imagine you have a toy car. So imagine you have like a Hot Wheels car, and when you push the car, it moves in a certain direction and it goes a certain distance. So a vector is like an arrow that shows both how far the car goes, and that's the magnitude, and which direction it moves. So if you push the car to your right for 10 centimeters, the vector would be an arrow pointing to the right with a length of 10 centimeters. That arrow is giving us two pieces of important information. Firstly, it's giving us the magnitude of the distance that the car moved, and that is 10 centimeters. And it's also giving us the direction in which the car moved, and that would be to your right. So vectors are important because they help us to understand how things move. For example, cars, balls, even people. So objects in general. How are vectors denoted? So a vector is denoted usually in bold text or with an arrow or line above the vector symbol. In this lesson, I'm going to use this notation. So I'm going to have the vector v, for example, and then it's going to be a line. It's just easier for me to draw. And you can also have an arrow. When you are writing out like vectors, it's kind of difficult to print what you have or write it in bold rather. But when you're typing it out, this V, that is in bold. Okay, so you can have it in bold, but when you're writing, the easiest way is to use an arrow or line above the vector. Now vectors can be represented, so that's how they are denoted, the symbol. How are they represented? How do we visually represent vectors? So vectors can be represented using a directed line segment, and that's just a fancy phrase for saying it's a line in a specific direction with an arrowhead. It's basically an arrow, right? Now, this directed line segment or arrow has two key features, and I want you to think back to the two important features of a vector. So the first one is the length of the arrow, and that represents the magnitude of the vector. And the second is the arrow points in the direction of the vector. So let's say we had a vector that looked like this, and then a vector with a larger magnitude would obviously be a larger arrow. So we can immediately see that this vector that I've just highlighted in blue has a greater magnitude than this smaller vector there, which has a smaller magnitude. And here is a diagram of what a vector, of how a vector is represented. So here's your arrow. Okay, vectors are represented with the directed line segment or an arrow. And the length is a representation of that line segment or that arrow is a representation of the vector's magnitude. The direction obviously is indicated by the arrowhead. So this looks like it's maybe, it's, what is it, northeast, more toward east. Okay. Now, two important things of this vector that you need to take note of. The starting point where that arrow begins, that is known as the tail. I like saying tail, but it's also called an initial point. So you'll see initial point commonly used in textbooks. I just think tail is easier to remember. All right. And the second thing is the arrow. That is known as the head, probably for arrowhead. Another common term that it's called, and you'll see it a lot in textbooks, is called the terminal point. So here's the initial point or the tail, and here is the terminal point or the head. Let's discuss displacement and vector addition. So displacement is a physical quantity that indicates the distance moved by an object in a specific direction. Hence, displacement is a vector. Now, just quickly, let's discuss the difference between displacement and distance. So distance is what is called a scalar quantity. So the key difference between displacement and distance is that distance only has magnitude. Okay, so for example, the distance from here to a shopping mall may be 50 kilometers. But when we talk about displacement, if I say something is displaced, it has been moved. Displacement is a vector quantity because it has a magnitude, so there's a distance that this object has been moved or displaced, and it also has a direction associated with it. So for example, if let's go back to that toy car example. If I move this toy car, it has been displaced. It's been displaced, let's say 10 centimeters to the right in our example. And then if I ask what is the distance that the car has moved, remember that distance is a scalar quantity. It only has a magnitude associated with it. Okay, you can think of it in an easy way. Think of distance as just a number. So the car has moved 10 centimeters. In what direction? We don't know. Distance doesn't reveal that information. So displacement is a vector, distance is a scalar. All right. So let's consider a car that moves from point A to point B. So on this diagram, let's have point A there, and here is point B, and there's also point C. We'll get to that just now. The displacement vector can be represented as AB. So remember, we're moving from point A to point B. This displacement vector, so the displacement vector AB, it has an arrowhead above it. This displacement vector has an initial point A, which is the tail. So let's represent the initial point there at A, and the terminal point or the head of this vector is at B. So there we go. Let's connect the initial point to the head of the vector. There we go. So that's how the car is moving. It's moving from point A to point B. The car then moves from point B to point C. So we're going from here to there. The displacement vector can be represented as BC, so BC with an arrowhead above it. This displacement vector has an initial point or the tail at B and the terminal point or the head at C. So we're going from B to C. The car is here right now, then it's going to C. So the displacement vector BC, it has an initial point at B and then it moves to C where the terminal point is. Okay, there we go. Now, if we add these two vectors together, so that's vector AB plus vector BC, the result is obtained, or the resulting vector rather is obtained, by placing the initial point of BC. So let's quickly look at that. Where's the initial point of BC? It's that red dot there. So we place the initial point of BC on the terminal point of AB. Now the terminal point of AB is where the arrowhead of vector AB is. Again, you can see that the initial point of BC and the terminal point of AB are the same. So we are placing the initial point of BC on the terminal point of AB, and we are going to get the resulting vector by connecting the initial point of AB, here is the initial point of AB, to the terminal point of BC. Here is the terminal point of BC. So let's do that. Let's actually connect these. So we go from the initial point of AB, that's basically point A. Okay, that's not a straight line. There we go. And we go to point C, which is the terminal point of vector BC. And there is my resulting vector. So this pink line, that is my resulting vector. Now, as you can see, this resulting vector has an initial point at A, where the tail is, and a terminal point at C, where the head is. And it is represented by vector AC. So here's AB, here's BC, and when we add these two vectors, AB plus BC, we get the vector AC. Now, this leads us to the definition of vector addition. If vector A and vector B are vectors positioned so that the initial point of vector B, the second vector, is on the terminal or head of vector A. So let's quickly draw a little diagram to see what we're doing. Here's vector A. Okay, there's vector A. And these vectors are positioned such that the initial point of vector B, so we're starting from here, there's vector B, is on the terminal. In fact, let me draw it like this. So here's vector A and here's vector B. Now we're going to draw these such that I'm going to take the initial point of vector B and place it on the terminal point of vector A. So it will look like that. The sum, vector A plus vector B, is the vector from the initial point of A, so from here, to the terminal point of B. So this is the resulting vector, and that is vector A plus vector B, and we'll call this sum, this vector sum, vector C. All right, let's do a quick example. So given the vectors vector A and vector E, draw the vector V where vector V is the sum of A and E. So no calculations required, just maybe copy down these vectors and take into account their direction and relative magnitude, and then draw the resulting vector V. Okay, so what I'm going to do is I'm going to copy this vector A, there we go, and I'm going to copy this vector E. And what we have is vector V, where vector V is equal to A plus E. So what we have to do is take vector A and E, and what we're going to do is take the initial point of E and place it on the terminal point of A, like that. The resulting vector then, which is V, is going to be from the initial point of A here to the terminal point of E. Then we just have to connect a line like that and have an arrowhead. So there is my resulting vector V. Okay, that's how it would look. So it has a smaller magnitude than both of these vectors. Make sure it has a smaller magnitude in the diagram that you drew, and it's pointing towards the southeast. It's pointing, if we think about this as, let's say, northeast, southwest, it's pointing in that direction. All right, let's discuss scalar multiplication. So consider a vector A and a constant number C. So C is a constant number like -5, 10, 3, 2, whatever the case is. And then you have some vector A. If C is greater than 0, so C is basically a positive number, then C times the vector A is a vector with the same direction as the original vector A, but its length or magnitude is now C, whatever the absolute value of C is. So if C was 7, you'll take 7 multiplied by the length of vector A. So let's say A had a length of, let's use centimeters as a measurement, or let's use units. Let's say A was 10 units in length. And now you're going to multiply this vector A by, let's pick C is equal to 7. Then the resulting vector CA, you'll take the absolute value of 7, and the absolute value of 7 is 7. Multiply it by 10, you'll get 70. So the resulting vector CA now has a magnitude or length of 70 units. And then what happens when C is negative? So let's consider that case. CA is a vector now with the opposite direction as the original vector A, and with a length or magnitude of, take the absolute value of C multiplied by the length of the original vector A. So this is best explained again using a diagram. Here is your original vector, and we call that vector u. What happens when I take 2 times the vector u? Well, 2 is a positive number, it's a constant. So what do? The new vector is in the same direction as my original vector u, so you can see that they are both, this vector and this vector are both pointing to the right. However, look at the magnitude of the vector 2u. Here's the magnitude of the first vector, let's say that is 1 unit. Here's the magnitude of the second vector, it's 1 plus another unit, it's 2 units. So it has double the magnitude, or basically 2 times the magnitude of the original vector. Okay, and if it was 3u, then it would be 3 times the magnitude, or 3 times the length of the original vector. 4u, 4 times. 5u, you get the idea. Then what happens if I take 0.5u? So 0.5, again, it's a positive number. So it's still going to point in the same direction. These two vectors here point in the same direction, to the right. However, the magnitude of the new vector is changed. You now have to take half the magnitude of the original vector. So where this is 1 unit, okay, this one here is now half a unit. Okay, it's half a unit in length or magnitude because the original vector has been multiplied by 0.5. And what happens when we have negative? So now negative u. Well, here's the original vector. It's pointing to the right, but we are now multiplying it by a negative, so the direction is now opposite. So the new vector is pointing to the left. And then in terms of what the new length or magnitude is, we're just multiplying the old vector by -1. So the magnitude is still going to be 1. Okay, and this one has magnitude of 1. The only thing that's changing here is that this vector is pointing in the opposite direction. What about a vector -2u? Well, there's two things that are happening here. Firstly, it's minus, so the direction is changing, and it's 2 times the original vector. So the magnitude of the original vector is going to double. So it's going to be pointing to the left, and its magnitude is going to double. That would be the vector -2u. So when you multiply it by a negative scalar, it changes the direction to the opposite. And when you are multiplying by a positive number, it's going to adjust the magnitude or the length of the original vector. Exercise 2. Given the vectors a and e, find a minus 3e, where a has a length of 3 centimeters and e has a length of 2 centimeters. So I've given you those distances so you can use a ruler and draw these. Take a minute and try it. Okay, all we need to do for this example is basically draw the vectors and find the resulting vector, which is a minus 3e. So we have vector e and we have vector a. So what I'm going to do is I'm going to copy a, and then we have minus 3e. So we are adding 3 times the negative vector e. So the negative vector e is going to be rotated in the opposite direction, and then it's going to have 3 times the length or magnitude of the original vector. So to be quite accurate, what I'm going to do is use the cool cut and paste tool on my tablet. Here we go. So that here, this here is minus 3 times the vector e, and we can get rid of these original arrowheads and we can just connect it. There we go. Okay, and then how do we get the resulting vector? We take this vector here and we place it on we take the initial point of that vector minus 3e and place it on the terminal point of the vector a, and the resulting vector will be from the initial point of vector a to the terminal point of vector minus 3e. So it will look like that. And then we can take out these other vectors. There we go. So this here is the vector a minus the vector 3e. Okay, and that's how you handle this example. So the important thing here to note was how to do scalar multiplication. To get minus 3e, there are two things that are happening. Firstly, you're going to triple its length because you're multiplying e by 3, and then you have to take it in the opposite direction because you're multiplying it by -3.